Good day everyone and welcome to this video presentation entitled Demystifying Forensic Ballistic Instrument, an area of science that plays an important role in solving firearm-related crimes. But before we proceed to the discussion of those instruments, let us first discuss what is forensic ballistics. Forensic ballistics is the scientific study of firearms, ammunition, bullets, and cartridge cases. In criminal investigations, ballistic evidence can reveal what gun was used, from what distance it was fired, and even whether two pieces of evidence came from the same weapon. Let's now discuss those instruments that is used in forensic ballistics. This instrument in a ballistic allow examiners to see details invisible to the naked eye. They ensure that the analysis of bullets, cartridge cases, and other evidence is precise, reliable, and legally admissible. Each tool has a unique role in this process, from initial observation to detailed measurement and comparison. Let's now discuss a bullet comparison microscope. A bullet comparison microscope is an advanced optical instrument composed of two independent compound microscopes connected by an optical bridge, allowing two specimens to be viewed simultaneously in a split-screen field. It is used to compare bullets and cartridge cases to determine whether they originate from the same firearm. The application of this one in a forensic ballistic, it is used to match microscopic striations and tool marks on bullets and cartridge cases. These marks include firing pin impressions, breech face marks, extractor and ejector marks, and barrel-produced striations. By comparing a bullet recovered from a crime scene with a test-fired bullet from a suspect firearm, examiners can determine if both were fired from the same weapon. These are the main parts and functions of bullet comparison microscope. First, eyepiece. The eyepiece allows the examiner to look into the microscope and view the combined images of the two bullets at the same time. Second, objective lenses. The objective lenses magnify the surface details of each bullet so that individual striations and tool marks can be clearly observed. Third, comparison bridge or optical bridge. The comparison bridge merges the two separate images coming from each microscope into one split field view, allowing direct side-by-side comparison of markings. Fourth, the magnification control knob. The magnification control knob lets the examiner increase or decrease the level of magnification to see either general patterns or very fine details on the bullets. Fifth, stages, left and right stages. Each stages holds one bullet or cartridge case and allow it to be moved, rotated, or titled so that specific markings can be aligned for comparison. 6. Bullet holders or clamps. The bullet holders secure each bullet or cartridge case firmly in place so that it does not shift while being examined. 7. Light sources or adjustable lamps. The light sources illuminate the bullets from the different angles to reveal fine striations, grooves, and other tool marks that are important for comparison. 8. The fine adjustment or focus knobs. The fine adjustment knobs allow the examiner to carefully adjust the focus on each side so both bullets appear sharp and clear in the combined view. Lastly, the base. Base supports the entire microscope structure and keeps it stable during the examiner. Second instrument is the stereo microscope. It's a low-power, three-dimensional microscope that provides a natural 3D view of the surface of an object. It operates using two independent optical paths, giving each eye a slightly different angle of the specimen. The application of this one in forensic ballistics. It is used in the preliminary examination of bullets and cartridge cases. It identifies class characteristics such as number of lands and grooves, direction of twist, caliber, and general condition of the evidence. It also reveals surface damage, manufacturing defects, and impact deformations. Let's now discuss the parts of the stereoscopic microscope and its functions. First, the eyepiece. The eyepiece allows the examiner to view the specimen with both eyes while also providing the initial magnification of the image. Second, the objective lenses provide low to medium magnification so that examiner can closely observe the surface details and markings on bullets or cartridge cases. Third, the zoom control knob smoothly adjust the level of magnification without the need to change objective lenses. Fourth, the focus knobs or coarse and fine. The coarse and fine focus knobs adjust the clarity of the image by raising or lowering the optical head until the details appear sharp. Fifth, the reflected or tap illuminator. Reflected illuminator shines light onto the surface of opaque objects, such as bullets, to make striations and surface marks more visible. 6. The transmitted or bottom illuminator. The transmitted illuminator shines light upward through transparent objects, although it is rarely used in ballistic examinations. 7. The stage plate. The stage plates serve as the flat surface where bullets or cartridge cases are positioned for observation. 8. The stand or arm. The stand or arm holds and supports the optical components, keeping them steady during examination. Lastly, the base. The base supports the entire microscope and houses the lighting systems that power the illumination or illuminators. The functions of this one, it provides a 3D image that allows detailed surface examination. It helps examiners see depth, texture, scratches, and the general shape of riffling marks or firing pin impressions. The significance of this one also, it is essential for initial analysis and documentation. It ensures evidence is suitable for comparison before using a comparison microscope. Third instrument is the comparison projector. A comparison projector enlarges two images simultaneously onto a screen for side-by-side comparison. It uses light projection instead of optical lenses. The primary application of the comparison projector in forensic ballistics is the side-by-side comparison of magnified images of evidence, bullets, or cartridge cases with control samples from a suspect weapon. This process allows examiners to visually match unique microscope marks like the striation from a barrel's riffling or riffling pin impressions to determine if both items were fired from the same specific firearm, providing crucial evidence in criminal investigations. Comparison projector parts and its functions. First, projection lenses. Enlarge the images of the bullets, cartridge cases, or tools so they can be clearly displayed on the viewing screen. Second, illumination lamps. Provide bright and even lighting to ensure that the details of the specimen are clearly visible when projected. Third, specimen holders. Securely keeps bullets, cartridge cases, or tools in place so they do not move while their images are being projected. Third, screen viewing surface. Displays the enlarged images side by side, allowing the examiner to compare them easily. Fourth, adjustable mirrors or prism guide and align the images properly so that the comparison between the two specimens is accurate. Lastly, focus controls. Sharpen the clarity of the projected images to make fine details easier to observe. The fourth instrument is the bullet recovery box. A bullet recovery box is a control device used to safely capture fired bullets without damaging the microscopic striations necessary for comparison. The application of this one in a forensic ballistics is the primary application is in the test firing process of a suspect firearm. It is used in the forensic laboratories to obtain known standards of fired bullets and cartridge cases for comparison with evidence found at a crime scene. The bullet recovery box parts and its functions. First, the moist waste or the front section. The moist waste slows down and cushions the fired bullet immediately upon entry so that it does not deform when it first makes contact. Second, the cotton or waste in the middle section. The cotton or waste material gently decelerates the bullet as it travels through the box, allowing it to come to a stop without damaging its riffling marks. Third, the sand in the rear section. The sand at the rear section acts as an additional stopping medium to catch high-velocity bullets that travel farther, ensuring they are fully contained. Fourth, the boilerplate backstop. The boilerplate backstop prevents bullet from exiting the box by providing a solid barrier at the far end. Lastly, the two lids. The two lids allow easy access to the inside of the box so that bullet can be retrieved after firing. And the outer wooden box holds the stopping materials securely and provides structural support for the entire recovery systems. The core function of the bullet recovery box is to safely decelerate and capture the fired projectile within a controlled environment using media such as cotton waste, water, or specialized synthetic fleece. The design ensures that the bullet is stopped without causing damage to the microscopic markings on its surface. The significance lies in the preserving the integrity of the ballistic evidence by keeping the unique ballistic fingerprints, station, and impression from the barrel, firing pin, and breech face intact. Examiners can use a comparison microscope to match the test bullet to the crime scene bullet, providing vital evidence to link a specific firearm to a crime and aid in criminal investigations. The fifth forensic ballistics instrument is the measuring projector. A measuring projector in forensic ballistics is used to determine and measure the precise class characteristics of a fired bullet, such as the width of lands and grooves, the overall diameter, and the rifling's pitch or twist. And also, the measuring projector's application is in the detailed analysis of fired evidence, specifically for determining the class characteristics of bullets and cartridge cases. This information is critical for narrowing down the possible make and type of firearm used in a crime before an individual characteristics are compared. Let's now discuss the parts and its functions of the measuring projector. First, the glass screen. The glass screen is the circular viewing surface where the enlarged shadow or profile of the object is projected so the examiner can clearly observe and measure it. Second, magnification lenses. Enlarge the profile of the part being inspected, allowing the user to examine fine details at different levels of magnification. Third, illumination. Systems provides a strong and focused light source that creates a clear shadow or outline of the object for accurate profile measurement. Fourth, the digital readout. The digital readout displays precise measurements values taken from the instrument, making it easy for the user to read and record accurate dimensional data. Fifth, the glass workstage is a flat, adjustable platform where the part is placed for inspection and it allows smooth movement along the X and Y axis to position the object correctly. Sixth, the encoders measures the exact movement of the workstage and convert it into numerical values, ensuring highly accurate and reliable measurements. The significance of these instruments lies in establishing objective and quantitative data early in investigation. The sixth instrument is the vernier caliper. A vernier caliper in forensic ballistics is a precision measuring tool used to determine the exact linear dimensions, such as the diameter, length, and depth of evidence, bullets, and cartridge cases. The vernier caliper is applied during the initial examination of physical evidence, specifically for obtaining precise, fundamental measurements of recovered bullets and cartridge cases. First part of the vernier caliper is the inch scale, which is used for measurements in inches. Second, millimetry scale, used for measurements in millimeters. Third, the workpiece, which is the object being measured. Fourth, fixed measuring jaw, the stationary jaw used to hold the workpiece against the moving jaw. Fifth, the moving measuring jaw, adjustable jaw that moves along the scale to measure the workpiece. Fifth, the cross tips, used for measuring the internal dimensions of an object. Sixth, the slide, the part of the caliper that moves along the reel. Seventh, the locking screw, used to lock the slide in place once the measurement is taken, ensuring accuracy. Eighth, the reel, the main body of the caliper with the measurement scales. Ninth, the verniers, a small sliding scale that provides more precise measurements. Lastly, the clamping lever, used to tighten the caliper onto the workpiece. Also, the function of this one is to provide highly accurate readings of external dimensions, internal dimension, and depth using its main scale and sliding vernier scale. Additionally, the significance of this measurement is establish the class characteristics of the evidence. The determined caliber and dimensions allow examiner to narrow down the potential makes and models of firearms that could have fired the ammunition, providing critical investigative leads to law enforcement and forming a basis for subsequent more detailed examinations. Seventh instrument is the analytical balance. An analytical balance in forensic ballistics is a highly sensitive instrument used to precisely measure the mass or weight of small evidence items like bullet fragments or gunpowder residue. Let's now discuss the parts of the analytical caliper. First, the glass door. The glass door encloses the weighing chamber to protect the sample from air currents and environmental factors that could affect the accuracy of the measurement. Second, the door handle. Door handle is used to open and close the glass door, allowing access to the balance pan while maintaining a controlled environment. Third, the balance pan. The balance pan is where the sample is placed to be weighed, providing a stable and level surface for accurate mass determination. Third, the anti-draft ring. The anti-draft ring surrounds the balance pan to further minimize the effects of air currents on the weighing process, ensuring stable and precise readings. Fourth, the display. Display shows weight, measurement, and other relevant information, such as the selected mode and any error messages. Fifth, the tare button. The tare button is used to zero the balance, subtracting the weight of any container or previous sample to measure only mass of the current sample. The mode button. The mode button allows you to select different weighing units or functions, such as grams, milligrams, or counting mode. Power button. The power button turns the analytical balance on and off, controlling the electrical supply to the instrument. Lastly, the level adjustment feet. The level adjustment feet are used to ensure the balance is perfectly level, which is crucial for accurate and reliable measurements. The significance of these precise measurements is to determine or confirm crucial class characteristics of the ammunition involved. The eighth instrument is the micrometer caliper. A micrometer caliper is applied during the initial forensic examination of fired evidence to obtain highly accurate, definitive measurements of minute dimensions. This often includes measuring the precise diameter of a bullet or bullet fragments, the thickness of a cartridge case base, or the width of the individual land and group impressions. Let's now discuss the parts of micrometer caliper, which we have the anvil. The anvil provides a stable, fixed surface against which the sample is held for measurement. Second, the spindle. The spindle is a movable part that is adjusted to contact the sample, allowing for precise thickness or diameter measurements. The measuring faces. The measuring faces are the surfaces of the anvil and spindle that come into contact with the sample, ensuring accurate measurements. And the U-frame, main scale, circular scale, and the sleeve with vernier graduations, and the thimble, the racket stop. The racket stop limits the amount of pressure applied by the spindle, preventing over-tightening and ensuring consistent measurements. The ninth instrument is the taper gauge. A taper gauge in forensic ballistics is a simple, wedge-shaped measuring instrument used primarily for quickly and accurately determining the bore diameter of the caliber of firearms barrel. The taper gauge is applied during the initial examination of a recovered firearm, specifically for the rapid and direct determination of the bore diameter or the caliber of the barrel. Its simple function involved inserting the wedge-shaped tool into the muzzle or breech end of the barrel until the sides of the gauge firmly contact the elevated portions of the bore. The significance of this one is the measurement lies in quickly establishing a crucial class characteristic of the weapon. The tenth instrument is the onoscope. An onoscope in forensic ballistics is a small, specialized optical instrument used for the internal examination of firearms barrel. The onoscope is applied during the internal inspection of a recovered firearms barrel. Its function is to provide a magnified illuminated view of the barrel's interior wall, and the significance of this one lies in understanding the precise condition of the barrel that produced the evidence markings. The 11th instrument, the helixometer. A helixometer in forensic ballistics is a specialized optical instrument used to precisely measure the pitch or rate of twist of the rifling inside a firearm's barrel. The helixometer is applied during the examination of a recovered firearm to objectively measure the rate and direction of the rifling twist, and the function of this one involves inserting a probe into the barrel and rotating it. A built-in dial or digital readout precisely measures how quickly the helical grooves within the barrel complete one full rotation, providing an exact, quantifiable measurement of the pitch of the rifling. Its significance lies in determining a key class characteristic of the weapon with high accuracy. The 12th instrument is the chronograph. A chronograph in forensic ballistics is an electronic instrument used to precisely measure and record the velocity or speed of a fired projectile. The chronograph is applied during the test firing of firearms and ammunition in a controlled laboratory or range settings. Let's discuss the parts and its functions of the chronograph. The first part is the diffuser. This provides consistent lighting conditions, ensuring accurate detection of the projectile as it passes through the sensors. The rods. These support the diffusers and maintain these positions relative to the sensors. Sky screens. These detect the passage of the projectile, triggering the timing mechanism to measure its velocity. And lastly, the display. This shows the measured velocity of the projectile, providing immediate feedback to the user. Additionally, its function is to measure the time it takes for a bullet to travel between two fixed points, typically placed a short distance from the firearm's muzzle. The significance of this one lies in providing the objective data essential for shooting incident reconstruction that will help the examiner. The last instrument is the shadowgraph. A shadowgraph is an optical instrument that uses a series of microscopic lenses and a large ground glass screen to perform preliminary examination and orientation of fired bullets and shells. It is primarily applied during the preliminary and rapid visual examination and orientation of recovered bullets and cartridge cases. At this moment, let's now discuss the parts and its function of the shadowgraph. First, the light source. The light source creates a shadow of the object being measured, which is projected onto the screen. Second, projection lens. Projection lens enlarges the shadow image, making it easier to see and measure fine details. Screen. The screen displays the self-height of the object, allowing for visual inspection and measurement. Lastly, measurement grid. The measurement grid on the screen allows for dimensional analysis of the object features, enabling precise measurements. And its function is to project a highly magnified shadow image of the evidence item onto a large viewing screen. Overall, the various forensic ballistic instruments, such as the bullet comparison microscope, stereoscopic microscope, comparison projector, recovery box, etc., work together to form a complete and reliable system for firearm and ammunition examination. Each instrument plays a unique role, from recovering bullets safely, to magnifying and comparing markings, to measuring dimensions with precision. Together, they allow forensic examiners to identify firearm signatures, analyzing firearm characteristics, and can accurately determine whether a particular weapon was used in a crime. Ultimately, these tools remind us that technology is a powerful partner in pursuit of justice. Through careful measurement, precise comparison, and scientific accuracy, forensic ballistics transforms tiny marks on bullet into undeniable evidence, helping reveal the truth, support fair investigations, and ensure that justice is served. And that would be all. Thank you for watching.